Wind is plentiful. It's just waiting to be captured and harnessed.
Wind is our fuel. We see it as a sustainable source for reliable energy.
As a renewables company, Vestas has a high stake when it comes to sustainability and carbon footprint reduction.
Vestas is the world's largest wind turbine manufacturer globally.
Our mission is to drive the world towards renewable energy. We have design elements that are kind of scattered around the globe. We have a centralized team in India, people in Denmark, in the United Kingdom, here in the US. We could be having a part shipped from Germany to the United States. In terms of sustainability, that is a substantial amount of fuel and time and resources.
The solution to that is direct digital manufacturing, or as we call it, DDM. We've equipped all of our blade manufacturing facilities with Markforged printers to have a rapid response to an ever-changing product.
We use it for instantaneous validation of design concepts. We use it for collaboration. We use it to free our manufacturing processes from the constraints of outside suppliers. With DDM, we don't compromise. What we've done to kind of flip the script is we're no longer just providing the instructions, we're providing the physical article in near real time. And it's the closest thing to teleportation I think you can get. Blacksmith has been mission critical for us to enable the functionality and the capability of inspection and calibration of a tool during the manufacturing process. Our blades, being ultra high up, inclement weather environments, they're prone to lightning strikes. So we incorporate a proprietary lightning protection system called a lightning tip receptor. Conventionally, just for the geometric aspects, something like this would be CNC'd out of a cheaper material like aluminum. The validation of that geometry and the fit and form and function, that could take weeks. We can validate this the same day as the design, and we could iterate numerous times, right? We could test one concept after the other, and then we can print the same exact design out of actual copper. You can't do that with conventional manufacturing. This is one half of a tool that's called the TC marking tool, or top center marking tool. It's used to place a witness mark or an indicator mark on our blades for the assembly process when it gets out to the field and goes up tower. So if the blade is out of clock position by even 1.5 degrees, that could result in a catastrophic failure. So we need to assure from manufacturing that we provide our colleagues in construction and assembly proper features to be able to align the blade to. A tool like this, the typical validation process, it would have to be taken to each physical specimen or each physical blade type to be checked. Well, with this, it manufactures the part, performs the blacksmith in-process inspection, calibration, so we guarantee repeatability every single time. We have full control over that because we know exactly what constituents, what inputs are going into the manufacturing process of that part. Now we can also generate actual calibration reports from it. And I can now stamp that part that it is in fact calibrated for use. We can automatically generate this and populate it, as well as a standard deviation and a heat map of what happened with that physical part. And then automatically upload that to our enterprise asset management system. So this all happens inside the Markforged X7 and inside of Eiger and Blacksmith. With Markforged, the blacksmith system, with the spirit of DDM, we can circumvent supply chain issue and do it all in one go. We can manufacture, calibrate, and generate a calibration report all in the time that it takes to manufacture the part. Markforged was selected because they were the most capable to provide the end-to-end solution we knew we had to have. It is a closed loop system. It's a closed ecosystem. Materials, machine, software, all of it, it's all encompassing. With the Eiger and Markforged platform, we can digitally store the instructions and manufacturing parameters in the cloud. And then we simply print that article, that tool or part, when we need it. It's a conventional FDM 3D printing technology, but it incorporates so much more with directional fiber and the composites, and then we have the added capability of metals. It's a full suite of manufacturing. We use the API integration aspect of the Eiger Fleet system We use RBAC, role-based access control. We use single sign-on, multi-factor authentication, all of the added functionality of Fleet. We use every single aspect of it. Another function within Eiger Fleet is custom analytics. So we can custom tailor specific KPIs, performance indicators, and metrics that we want to measure. What's important to us as an organization to understand what is the impact, right? What is the dollar value? What is the ROI? The user has to input what was the original cost of the part, the original weight, the original lead time. And then we could use those for business analysis. All of those things are key metrics for us to understand, is this successful as a concept? We've been able to deploy these systems to places where people hadn't even seen 3D printers. We can put them in factories where there's no core competencies around additive at all. Provide them with about 3 hours of training on, hey, this is how you take care of the machine, this is how you load material, and the printers are making parts with no problem. We're essentially putting the power of manufacturing into the hands of our end users, democratizing manufacturing while maintaining a centralized engineering control model. We can almost eliminate a lot of our supply chain related carbon footprint. Conventionally, this tool would take 3 weeks to manufacture. With DDM, direct digital manufacturing, from design to printing, assembling, and putting into the hands of production for validation was 3 days. We were immediately able to post it for global use. So Markforged and the Digital Forge platform is manufacturing without borders and without limits. It is a game changer in manufacturing.